Today we are going to see numerical methods and linear algebra. Before learning the methods, let us understand why numerical methods are important. In engineering, many problems cannot be solved exactly. So we use numerical methods to get accurate approximate solutions. So these methods are used in electrical engineering, electronics and communications engineering, mechanical engineering and automobile engineering. So numerical methods are very important for every engineer. Now let us learn our first topic, interpolation. In this chapter, we will study three important topics. The first topic is interpolation. Interpolation helps us to find a missing value between two known values. The second topic is numerical differentiation. This method helps us to find the rate of change when we have only a set of data instead of a mathematical equation. The third topic is numerical integration. It is used to calculate the area under a curve when finding the exact answer is difficult. Under interpolation, we will learn four methods. First is interpolation with equal intervals. Second is interpolation with unequal intervals using Lagrange's interpolation. Then we will study Newton's forward difference method. Finally, we will learn Newton's backward difference method. For numerical integration, we will study the trapezoidal rule, Simpson's rule and double integration. By the end of this video, you will know how engineers estimate unknown values using these numerical techniques. Before we start, let me ask a simple question. Imagine you are traveling on a bike or a car. Your GPS shows the location of two petrol stations. One petrol station is 5 kilometers away and the next one is 15 kilometers away. But you want to know where a small shop or charging station might be between these two locations. So, how can we estimate its positions using the available information? So, this is exactly the idea behind interpolation. So, engineers know only a few measured values, but they need to estimate the value in between instead of measuring every single point. They use mathematical techniques to find the missing values accurately. So, in this chapter, we will learn these techniques. These methods are widely used in engineering, data analysis, weather forecasting, electrical systems, and many other real life applications. So, now let's begin our lesson. Now, let us understand the meaning of interpolation and extrapolation. So, interpolation means finding an unknown value between two known values. For example, imagine an engineer measure the temperature of a machine. At 10 a.m., the temperature is 30 degrees Celsius and 12 p.m. it is 34 degrees Celsius. If you want to find the temperature at 11 a.m., we use interpolation because 11 a.m. is between 10 a.m. and 12 p.m. Now, suppose we want to predict the temperature at 1 p.m. Since 1 p.m. is outside the given data, so we use the extrapolation. So remember, interpolation means inside the given data, extrapolation means outside the given data. Okay, now the question is, how do we choose the correct interpolation method? The answer depends on the spacing of the given data. If the distance between the x value is the same, we say the intervals are equal. For the intervals, we use forward difference method or Newton's backward difference method for equal intervals. If the spacing between the x value is not the same, the intervals are unequal. So in that case, we use Lagrange interpolations method. So before solving any problem, always check whether the intervals are equal or unequal. So this is the first step in choosing the correct method. So now next we understand two important concepts, forward difference and backward difference. Before applying Newton's forward interpolation formula, we need to prepare a difference table. A difference table shows how the values change from one observation to the next. Now let us learn. In the first column we have the x values. In the second column we have the corresponding y values. The next column contains the forward differences delta y, delta squared y, delta cube y and delta power 4y. So first we calculate the first forward difference. We subtract two consecutive y values. That is delta y naught equal to yn minus y naught. And the second one delta y1 equal to y2 minus y1. Then delta y2 equal to y3 minus y2. Delta y3 equal to y4 minus y3. So each difference is obtained by subtracting the previous y value from the next y value. Next we calculate the second forward difference. Here we subtract two consecutive first differences. Delta squared y naught equal to delta yn y1 minus delta y naught and delta squared y1 equal to delta y2 minus delta y1 and delta squared y2 equal to delta y3 minus delta y2. Similarly, the third forward difference is calculated by subtracting two consecutive second differences. Delta power 3 y naught equal to delta squared y1 minus delta squared y naught and delta cube y1 equal to delta squared y2 minus delta squared y1. Finally, we calculate the fourth difference. So delta power 4 y naught equal to delta power 3 y1 minus delta power 3 y naught. So remember, in Newton's forward interpolation, we use only the upper diagonal values of the difference table. So next, let us understand the backward difference table. First, write the given x values and y values. Next, calculate the first backward difference by subtracting two consecutive y values. For example, del y1 equal to y1 minus y0, y1 minus y0. Then del y2 equal to y2 minus y1. Then del y3 equal to y3 minus y2 and del y4 equal to y4 minus y3. Then calculate the second, third and fourth backward differences in the same way by subtracting consecutive values. In forward and backward differences are used only when inputs are equally spaced. Then the forward difference table is effective for obtaining the missing data from the first half of the given data, and the backward differences is effective for obtaining the missing data from the last half of the given data. Now let us understand how to construct a forward difference table using this example. The given values are x is equal to 1, 2, 3, 4, 5 and y equal to 4, 13, 34, 73, 136. Since the x values are equally spaced, so we can use the forward difference method. The first forward difference is calculated by subtracting consecutive y values, that is 13 minus 4 equals 9. 13 minus 4 equal to 9. Then 34 minus 13 equal to 21. So 73 minus 34 equals 39. Then 136 minus 73 equals 63. Next, we calculate the second differences by subtracting consecutive values from the first difference columns. Finally, the fourth difference is 6 minus 6, which is 0. So these upper half diagonal values are used in Newton's forward interpolation formula. Now let us construct the backward difference table. First, calculate the backward differences. The first differences are 9, 21, 39 and 63. The second differences are 12, 18 and 24. The third differences are 6 and 6. So finally the fourth difference is 0. So for backward difference interpolation, we use the values along the lower diagonal del y4, del square y4, del power 3y4 and del power 4y. So I hope you understood today's session. One, today we are going to see numerical methods and linear algebra. Before learning the method, today we are going to see numerical methods and linear algebra. Before learning the method,